Welcome back to P2. Today we are looking at using tangent and chord properties within our circles. So as a bit of a recap, a tangent is obviously going to touch a point in one place. So a tangent to a circle will touch it just in that one place, or that one point on the circumference. And the tangent is always perpendicular to the radius of the circle at that point, as I've just shown here. So you can see the tangent here crosses or touches just in one point, and then at 90 degrees to that you find the radius. Now when it comes to a chord, now chord is obviously a line that touches two edges of a circle, a bit like the diameter, except for that it doesn't go through the diameter. Now in terms of the chord's perpendicular bisector, which I'm trying to demonstrate here, though maybe not the perfect one, it goes through the center of the circle, which means that these two lines either side are equal in size. So it's quite important to understand that. So just remembering the perpendicular bisector of the chord will always pass through the center of the circle. So this example here, we have the point P lies on the circle which has center 4, 6. Find the equation of the circle and then find the equation of the tangent to the circle at P. So you don't need to sketch it to be able to solve this, but I've just put a very quick sketch down just so that you can see what we're looking at. It's sometimes more important to do a sketch when that problem becomes a little bit more information or a little bit more challenging with several things on it. A sketch will help. So equation of the circle. So we got x minus a, which will be 4, plus y minus b, which will be 6. And then of course we've got r squared, which we don't know yet. Now we know that between P and the center is going to be the radius of the circle. So all I need to do is find that length of the radius. So the radius is going to be, using Pythagoras, we'll have the difference in the x's squared plus the difference in the y's squared. Remember, when you're doing this, whichever x you start with, you have to start with the corresponding y. So I started with 4 from this one, so I also need to use the 6 first. And then it's 1 and the minus 2. I could start with this one first as well. It makes no difference whatsoever. So 4 minus 1 is 3, squared is 9. 6 plus 2 is 8, squared is 64. So I've got the square root of 73 here. So when I go back up into my equation, it's obviously r squared I want. So we've got x minus 4 squared plus y minus 6 squared equals 73. Now, part B, we want to find the equation of the tangent. I've got one of the points. What I could really do with is the gradient. So let's look at the gradient of the radius, which is P to the center of the circle, which I'll call C. So this distance, or the gradient of PC, which I'm just going to put as m, it's going to be the difference in y's, 6 minus 2, over the difference in x's, 4 minus 1. Remember again, start with the same x and y. So same x and y, the coordinates are above each other. So on the top you can see I've got 8 over 3. And that's the gradient of my radius. I'll put a little r there for radius. And we want the gradient of our tangent, which is going to be inverse of it and change the sign. So minus 3 over 8. And the coordinate of the tangent is 1 minus 2. So now I can go to my y minus y1 equals mx minus x1. Obviously you can use y equals mx plus c if you want to. So y minus minus 2 is minus 3 over 8 x minus 1. So we've got y plus 2 equals minus 3 over 8 x minus 1. I'm taking extra steps here that I would skip some of these sometimes. Now, because I got a fractional gradient, it's usually better than to leave this in the form ax plus by plus c. So let's multiply by 8. So 8y plus 16 equals minus 3 times my x and minus 3 times my minus 1. I'll do that one in one go there. Now we want the x really to be positive, so let's get it on the left. 3x plus 8y, we're going to take away 3, so it's going to be plus 13 equals 0. And there's the first example done. So here we have the points A and B that lie on a circle C. We have the equation of the circle. We need to find the equation of the perpendicular bisector of the line AB and then show that it passes through the center of the circle. So here is just a very quick sketch of my circle and what I've got on here. So the first we want to find the equation of the perpendicular bisector of the line AB. So let's find the gradient of AB first. So this is difference in y's over difference in x's. So on the top, minus 5 plus 9 is going to give me 4. 7 plus 1 is 8. So we've got a gradient of a half. So in terms of my perpendicular bisector, that's going to be at 90 degrees to AB, so it's going to be negative 2. Now, normally, we would use the coordinates 1 and minus 3 to find the equation of this straight line, but we can't use 1 and 3 because clearly we're going to have to use that in the part B to show that it goes through the center of the circle. So what we need to do is we need to use the midpoint here. So the midpoint of AB. So what I want to do is I want to find the midpoint of AB first. So the midpoint of AB is adding up my x values and dividing by 2, and then add up your y values and divide by 2. And that's obviously how you get your midpoint. Now that I have my midpoint, which is 3 minus 7, I can use my y minus y1 equals mx minus x1 or y equals mx plus c to find the equation of this straight line. And that leaves me with y equals minus 2x minus 1. Now, for part B, I need to show that the perpendicular bisector of AB passes through the center of the circle. So I want to substitute the center of the circle, which is 1 minus 3, into my equation and show that it works. So we've got y equals, so we should have minus 3 out here, so minus 2 minus 1 is minus 3, and that is exactly what we were expecting. Okay, and that's essentially all we need to do to kind of prove this. Now remember that A to P, A is the center of the circle, P is on the edge, so this is a radius here. And then we've got the tangent of P that hits R. So this is a tangent to the radius. So it's got to be 90 degrees, and that's important for us to be able to find the area of this triangle. So we want to find the distance PR, and we want to find the distance AP. Now the distance AP is the radius of the circle, which is the square root of 53. And all I've got left to do here is find the distance PR. So finding PR, we want the square root of, and then it's going to be the difference in my x's. So 0 minus 7 squared plus the difference in my y's. -4 minus 6 squared. So we're looking at the square root of 7 squared plus 2 squared. And 7 squared plus 2 squared also happens to be root 53. So area of triangle APR is going to be a half times base times height, or 53 over 2. 26.5 units squared. Okay, just a bit of a coincidence here. It's not always going to be the same value. Now with this question, if this equation is a tangent with a circle, then we can equate it. So we've got 2x plus y minus 5 equals 0. And we've got the equation x minus 3 squared plus y minus p squared equals 5. Now,